Today we'll be looking at chemistry, Igcse, paper 4, May, June 2023. Paper 4-3, May, June 2023. Without much ado, let's quickly begin. Now, here are some questions. We have some symbol equations and word equations from A to J, and they're shown. Now, let's take a look at the first one. Hydrogen ion plus hydroxide ion gives water. Chromium plus hydroxide ion gives chromium hydroxide. Methane plus chlorine gives chloromethane and hydrogen chloride. Okay, and then propene plus bromine gives 1,2-dibromopropane, and then the K can be catalyzed, can be broken down into smaller units, ethene and octane. And then fluorine can be fluorine react with aqueous potassium bromide to produce bromine and aqueous potassium chloride, because chlorine is higher than bromine, so chlorine will displace bromine from the potassium bromide to become potassium chloride. And then we have methane plus oxygen react together to form carbon monoxide and water, and we have propanoic acid react with methanol to produce ethanoate, methyl ethanoate, and water. And then we have hydrogen react with oxygen to produce water, and we have carbon dioxide react with water to produce glucose. Carbon dioxide, you remember, from the air to the leaf, and the water from the root goes to the leaf of the plant to produce glucose and oxygen. So this one, J, is photosynthesis, and so on and so forth. So they've given us quite equation, 10 equations. They use the equations to answer the questions that follows. Now, each equation may be used once or more than once, or not at all. So not everything. Sometimes some may not be used, so you don't have to worry if you don't find any particular equation. Give the letter A to J. So we're going to use the letter A to J for the equations which represent any one dimension. Photosynthesis is J, right? As we have rightly pointed out, photosynthesis is J. Why? Because this is carbon dioxide react with water to produce glucose which is food, and oxygen. So this process is photosynthesis. So we just put letter J, we get 1 mark if we're able to do that. Then addition reaction. So we take a look at addition reaction. We go to the equation that probably is an addition reaction. You see, propene is not propane. This is the alkene family. React with bromine to become this one we can write the equation if we want. React with bromine. So bromine will fill this place of hydrogen. You know, 2 hydrogens are missing. So 2 bromine atom, which is dibromo, which is bromine atom like this, 2 bromine atom, Br2. So we have 2 bromine atom. Okay, it's laggy anyway. Okay, so 2 bromine atom, we feel, you know, propene is shorting. To make it propane, it doesn't have 2 hydrogens, less with 2 hydrogen. So bromine will replace it, become 1,2-dibromopropane. You see, the name now become propane, not propene. Become propane. So this is an addition reaction. This is called addition reaction. Okay, this is called addition reaction, D. So D will be for the second case, addition reaction. Then a precipitation reaction. Which of the reactions is a precipitate? Of course, this one. You can see the ion react with hydroxide to form chromium hydroxide. So this, a precipitate is formed. A precipitate is formed in case of B. Okay, a white precipitate is formed in the case of B, the second one. So this is a precipitation reaction. Now, incomplete combustion. You know, incomplete combustion is when oxygen bonds with gas like methane. Any gas, methane, ethane, any gas bonds in oxygen. Instead of producing carbon dioxide, produces carbon monoxide. It produces carbon monoxide. So we look at the equation where that takes place. methane bonds in oxygen. Instead of forming carbon dioxide, it forms carbon monoxide. This is incomplete combustion. This is called incomplete combustion. If there is excess, and it normally happens when there is no excess oxygen. If the oxygen is in excess, it will produce carbon monoxide, and it will become a complete combustion. So incomplete combustion is G. So the reaction for incomplete combustion is G. Then a displacement reaction. Displacement reaction is the one where chlorine displaces bromine, right? Where chlorine, because it's higher in reactivity series, it displaces bromine. When we have chlorine plus potassium bromide, you produce bromine separate, and then the chlorine will replace this bromine in the potassium bromide. So instead of having KBr, it will be displaced. The end result will be KCl, will be potassium chloride. This is a displacement reaction because chlorine is higher in the halogen family. This one is higher. Chlorine is higher than bromine, right? Sorry, chlorine is higher. Here's chlorine, Cl2. So it's higher than bromine. So you produce what? Potassium chloride. So this chlorine will displace bromine here, and then bromine will be separate. Now will be on its own. It will be displaced. Right? So when we say displacement reaction, is this reaction. Displacement reaction is this reaction. Okay, so this one is a displacement reaction. So the next question is a substitution reaction. Substitution reaction is the one that entails us replacing, substituting, where you need UV light or something. Methane plus chlorine, you form chloromethane. This is a substitution reaction. So instead of CH4, you have CH4 in the case of methane. You have CH4. When it reacts, other UV light. This happens, substitution reaction happen other UV light plus chlorine. This will give you chloromethane. So one hydrogen atom will be replaced with one chlorine atom. So you have CH3. You now have CH3. One hydrogen atom will leave, and then one chlorine atom from here we join it. It will be CH3Cl plus the hydrogen atom that left, we combine with the remaining chlorine atom. There are two chlorine atoms. We combine with the remaining chlorine atom. There are two chlorine atoms. One we chase one hydrogen atom here away, and that one that is left, we join with the remaining one to form hydrogen chloride. Hydrogen chloride and chloromethane will be formed. So this is called a substitution reaction. It's called a substitution. And this will happen under UV light, ultraviolet light. We cause it to happen. So these are the first options of the questions that we have. So, and that's for question 1. So if you're able to do that, you get your 6 marks. We'll go to question 2. Let's run quickly through these questions so that we can finish this paper as fast as we can. Now the symbols of elements in period 3 of the periodic table are shown. Now we have sodium, we have magnesium, we have aluminum, we have silicon, we have phosphorus, we have sulfur, we have chlorine, we have argon. The symbols are only given. Now use the symbols of the elements in period 3 to answer the questions that follow. A symbol may be used once, more than once, or not at all. Now give the symbol of the element that is present in purified bauxite. Purified bauxite, we obtain aluminium from bauxite, right? So purified bauxite is aluminium, and aluminium is just Al. So that's that for that. Then we go to the next one. It says the name of the element that contains atoms with a full outer shell of electron. Full outer shell of electron is argon. Those ones that are in we call them the group 8, or group 0. Okay, they have complete 8 electrons in the outermost shell, like argon. First, like helium, there is no helium in the list. So helium is the very first one that completes its outer electrons. Helium is 2 electrons, but that's the only one, and the first electron must be 2. The next one is neon, which with atomic number 10 That's if you write the electronic configuration to be 2, 8. So that one has 8. The next one is argon, 2, 8, 8. 8 is, so once you have 8 in your outermost electron, then you fall in that category. Now, it says it's used to kill microbes in water treatment. Is chlorine. We use chlorine for killing microbes in water. You know, if you go to treatment plants where we purified water, after we boil water in the water industry, the next thing we add chlorine to it to kill the remaining bacteria, to kill. So chlorine is used to kill microbes in water treatment. Is that okay? So take note. It's used for, chlorine is also used for bleaching and is used for killing microbes in water. Now the next one is elements that form an amphoteric oxide. It's same aluminum. Aluminum can form a basic oxide. What we mean by amphoteric oxides, oxides that can act as acidic oxide and as well can act as basic oxides are called amphoteric oxides. So aluminum can act as acidic oxide and can also act as a basic oxide. So Al. So we write, so you can see aluminum is used twice now. And then form an oxide which causes acid rain, sulfur. Sulfur reacts with oxygen to form sulfur dioxide. Okay? And sulfur dioxide reacts with water to form acidic rain. Is that okay? Okay, so that's that for that. Now the next one has an oxidation number of -1 when it forms a compound with hydrogen, of course chlorine. The hydrogen has one proton, H+, which you can give to chlorine and form a covalent bond with chlorine. So chlorine has -1. Why? Because it's looking for one electron or one atom to complete its outer shell. So chlorine has appeared twice, aluminum has appeared twice, and some elements like sodiums were not used, right? Phosphorus were not used, and so on and so forth. Silicon was not used, and so on and so forth. Okay, so that's that for that. Now we go to the next question. It says, the B part of the question 2 says, the relative atomic masses of elements can be calculated from the relative masses of the isotopes and their percentage abundances. Now identify the isotope to which all relative masses are compared. They are compared with carbon-12 isotope. Okay, this is the basis for relative atomic mass, carbon-12 isotope. Even in the definition of relative atomic mass, this as compared to carbon-12 isotope is the end of the definition, as benchmarked or compared with carbon-12 isotope. So carbon-12 isotope, so you write C and 12 in the back here, not in the front here, okay? So that's what it is. Now we go to the next question. Say, table 2.1 shows the relative masses and the percentage abundances of the two isotopes in a sample of magnesium. Okay, so let's say magnesium, you know the magnesium mass of magnesium is 24. Relative masses of isotope 24, and the percentage of abundance for this one is 85%. So 85%, we're going to do 85 over 100 times 24 to know the percentage of abundance of this one. For this one, magnesium 20 is isotope magnesium 26. Percentage of abundance is only 50. So we just say 50 over 100 times 26. So we can do it together as a sum by just saying this 85 times 24 plus 50 times 26, or everything over 100, everything. Instead of doing this over 100 and this over 100, it's the same thing, still going to be the same thing. Okay, because 100 is their common denominator. So if you do this calculation, you get 24.3 and you are good to go with these 2 marks. Is that okay? So that's that for this question. Now we move to the C part of the question. Is an iron contains 10 electrons. Ion. An ion contains 10 electrons. You know ion, right? Ion is either an atom that has lost electron or gained electron. If you lose electron, you become an ion. When atoms lose electron or gain electron, they become ions. So we say an ion contains 10 electrons, 30 protons. So proton is higher than electron. What it means? It means it has lost electron. So this is a metal. It has lost electron. If it's 13, so this is going to be aluminum. This is definitely, if the proton is 13, because number of protons is the atomic number. Okay, so this is aluminum. So if it's 30 proton, it means the atomic number is 13. And element in periodic table 13 with atomic number 30 is aluminum. And 14 neutron, it has neutron. So you can find the mass. To find the mass is the number of proton plus number of neutron. That's 27. the mass number or nucleon number. They call it nucleon number, nucleon. Okay? Now it says state the nucleon number of the ion. So you can see the nucleon number is to add what? The 13 number of proton plus number of neutron to get the nucleon number. Which we we have a formula for it. The A equal to Z plus N. The nucleon number, Z is the number of proton or the atomic number, plus N is the number of neutron. So you write this formula and then you find your nucleon number. Nucleon number is same as mass number, which is 27. You get this one. Then identify the element that forms this ion. Of course, it's aluminium. Why? Because number of proton is 30, so aluminium is 13 in the periodic table. 11 is sodium, 12 is magnesium, aluminium is 13, so it's aluminium. You get your 1 mark. So we're done with the second question. Now let's move to question number 3. So we'll move to question number 3. For question number 3, it says that magnesium forms ionic compound. Magnesium forms ionic compound. Yeah, of course. Why? Because magnesium is a metal, so it's going to lose electrons. It loses 2 electrons in the outermost shell. It has 2 electrons in the outermost shell. First shell has 2, second shell has 8, that's 10 to 2 of 10. Third shell, it has 2 electrons because it's 12. Atomic number is 12. So it will lose 2 electrons. So it's an ionic compound. Atoms that lose electrons or gain electrons, they are ionic compound. Covalent ones are the ones that share. They don't lose. They don't donate. Okay. Magnesium reacts with fluorine to form ionic compound magnesium fluoride. Right? Remember, fluorine is in the halogen family. So fluorine has 1. It's looking for 1 because it's in group 7 of the periodic table. So it's looking for 1. It already has several electrons in the atmosphere. So magnesium loses and then react with the form magnesium fluoride. Right? Now the electronic configuration of an atom of magnesium and atom of fluorine are shown in figure 3.1. Now let's take a look at that of magnesium atom. You can see the first shell has 2 electrons. The second shell has 8 electrons. The third shell has only 2 electrons, right? Which is these 2. And then for fluorine, first shell has 2, second shell has 7. So what happens is that ions are formed. Sorry, 1 minute, okay. Ions are formed by the transfer of electrons from magnesium atoms to fluorine atoms, right? The transfer of electrons from magnesium atoms to fluorine atoms. Just so my computer is going off. Let me quickly plug it. Okay, ions are formed by the transfer of electrons from magnesium atoms to fluorine atoms. Now complete the dot and cross diagram in figure 3.2 to show the electronic configuration of one magnesium ion. Not the, magnesium is going to lose 2, but they just want for 1 magnesium ion and 1 fluorine ion. Okay, and then 1 magnesium ion and 1 fluorine ion. They show the charges on the ions. Okay, magnesium, it has 2, right? So we're going to complete this one. Go to magnesium. The second one is 8, right? So we have 8 here. Then the third one, right? The third one. So here we have 8. 1, 2. Okay. Or you might just draw the outer shell one. But that's if they say so. Okay. Okay. So here we have two, right? Two electrons in the atmosphere. Okay. So magnesium is going to lose 2. So you say +2 here. You have to write this +2. If you don't write this +2, you're not going to get the max. Right? Then for fluorine, because normally we are supposed to have another fluorine atom. Because this one has 2. He will give one to this one, and then he will give the other one to the other fluorine. But they just want to show for one case only. So we do for the second one. This one has 8, and then here has 7. So here we have 1, 2, 3, 4, 5, 6, 7, 8, and then here we have 7, 1, 2, 3, 4, 5, 6, 7. So here we do only 7, and then we know this one will give 1 to this place, and then we show that cross. We use a cross to represent, showing that that cross is coming from here. The cross is coming from here, this one. Only one of these atoms comes here. Okay, only one of these atoms comes here. So we're able to get our marks. We'll be able to get our full 3 marks. If you don't give this number of ion here, you lose like at least 1 mark. If you are not able to draw this one, show that one atom here, 1 electron here is the one that comes here, you also lose. So you have to be able to do all of this to get your 3 marks complete. Now let's go to, it says, deduce the formula of magnesium fluoride. Now how do we deduce the formula of magnesium fluoride? You remember what you do, you've done this one severally. You write your magnesium, you write your fluorine, right? Let's write their ions. Magnesium, because it gives 2 electrons, it has 2 electrons in the atmosphere, you write 2 here. We don't use their sign, fluorine has 1. So this one is usually -1. But we don't normally use their sign where we are cross multiplying. So what we do, we cross multiply. 1 times magnesium and 2 times fluorine. So you do this, magnesium times 1. You write metal first. So you write magnesium times 1 is 1. So you no need to write 1. Then fluorine times 2 is F2. You write F2. The 2 is a small substrate. So with this you get your 1 mark. If you're able to write magnesium F2, you get your 1 mark. Now we go to the next one. It says when solid magnesium fluoride is dissolved in water, it forms a solution that conducts electricity. When solid magnesium fluoride is dissolved in water, it forms a solution that conducts electricity. One other change that can be made to solid magnesium fluoride to allow it to conduct electricity: melting. Okay, when you melt it, it will conduct electricity. Melt is one change that can happen to it, and it will conduct electricity. Now, the B part of the question says silicon tetrachloride, SiCl4, and silicon 4 oxides, SiO2, are covalent compounds. Covalent means they share electrons. No one donates to anyone. It's bonding. You bring, I bring. Cooperation. You bring, I bring. Okay? Now I say complete the dot and cross diagram in figure 3.3 to show the electronic configuration in a molecule of silicon tetrachlorides, and show outer share electron only the outer share electron. So they don't want all you drawing the first share of chlorine, second share of chlorine? No, only the outer share electron. Now chlorine, the outer share has 7 electrons. So assuming we are using cross for chlorine, we're using the cross for chlorine. So you can see we have 7, 1, 2, because chlorine is 2, 8, 7, right? We're only doing for the outer share. We're not doing for the first share, we're not doing for the second share, and we're only doing for the outer share because atomic number is 17. So the number of proton is 17, number of electrons is 17. So we are doing for the outer share of chlorine 7. So that's how we have this 7 cross. 1, 2, 3, 4, 5, 6, and 7. Now you see silicon. Silicon has only 4, right? Because silicon is atomic number is 14. So we have 2, 8, 2, 8, 4. For silicon is 2, 8, 2, 8, 4. So the outer share electron for silicon is 4. So what this silicon will do, it will give 1 here. You share 1 with chlorine. Chlorine has 1 here because you already complete 2 here, 2 here, 2 here. So the 7th one is here. So silicon will give 1 here. So this one is already complete 8. You can see this chlorine is already complete 8. Now the same happens to chlorine and silicon from this side. 7 chlorine, 1 silicon. Because silicon was before, it has 4 in the outermost share. 1 here, 1 shared with this bond, with this atom, 1 shared with this atom, 1 shared with this atom. These are the 4. 1, 2, 3, 4. These are the 4. Then each of the chlorine shares their 7th one. 7th one here with this one, 7th one here with this one, and 7th one here with this one. So if you now look at every bond, this one is complete 8. This one, even the silicon is now complete 8. Because chlorine has given 1, 1, 1, which is 4. Silicon give 1, 1, which is 4. That's 8. If you look, you go this way, everything is 8. If you go this way, everything is 8. If you go this way, everything is 8. This is called the silicon tetrachlorine. Silicon tetrachlorine. So this is the bonding. What happens? If you're able to do this, you get your 2 marks in the exam. You get your 2 marks. So we'll move on to the next question. Now it's the melting point of silicon tetrachloride and silicon 4 oxides are shown in table D, blah, blah, blah. Silicon tetrachloride is negative 69, very low melting point. And silicon 4 oxide is 1704. So the melting point of silicon 4 oxide is very high compared to silicon tetrachloride. So what would be the big difference? Silicon tetrachloride has a low melting point because it has a weak forces of attraction between the particles. Very weak force, that's why it can melt easily. Now name the types of particles that are held together by these weak forces of attraction. Molecules. You can simply say molecules. Okay, the spelling here is not correct. Molecules. Okay, molecules. Okay, molecules. Okay, so you get your 1 mark. We go to the next one. Explain in terms of structures and bonding why silicon 4 oxide has a high melting point. Why does silicon 4 oxide has a high melting point? Remember, silicon 4 oxide is similar to that of diamond. The structure is similar to that of diamond. Silicon 4 oxide, diamond, they have very strong bonding. They have similar bonding system. Silicon 4 oxide has a big covalent structure, a very big. That's why I say it's like diamond. You know, diamond has a very big covalent structure. Every 1 carbon atom is bonded to 3 other carbon atoms. So it has a very big covalent structure, and it requires a very large amount of energy to break it, because it has a very giant it's a giant micromolecule. Okay, so because it has giant micromolecule structure, is difficult to break the bond. So for that reason, it's what? For that singular reason, it has a very high melting point. Okay, it has a very big covalent bond structure and requires large amount of energy to break. So you get 2 marks. If you're able to write these 2 points, you get 2 marks. Now let's go to question 4 on this paper. Now we say hydrogen is produced by a reaction between zinc and dilute sulfuric acid. Zinc react with an acid, dilute sulfuric acid, aqueous, okay, to produce what? Zinc sulfate. Because zinc is higher than hydrogen in the reactivity series, zinc will displace hydrogen. It will now be zinc sulfate, not hydrogen sulfate, what you call sulfuric acid. So it will be zinc sulfate plus hydrogen. The hydrogen that is displayed will be a gas on its own. Now, a student carries out an experiment using excess zinc and dilute sulfuric acid, right? Now, the student measures the volume of hydrogen produced at regular time interval using the apparatus. Okay, this one will give you rate of reactions, and you're able to calculate the amount of gas produced. Tells you how the reaction rate, how it's going. Okay, so it's a lumps of zinc are used. They use lumps of zinc. So lumps of zinc, the reaction will not be as fast as when you use powder zinc. Powder zinc has a larger surface area, so it will react faster than lumps of zinc. Because lumps of zinc will take time to dissolve in the acid. But powder will dissolve faster and the reaction will be faster. Okay, now let's see what question they're going to ask us. You can see the series, where the gas, hydrogen gas will be measured. You know, when this is the acid, this one that looks like liquid. These lumps are the zinc. This is the acid, sulfuric acid, this one. So the acid will be melting the zinc. So it will melt and forms zinc sulfate. And the hydrogen gas that is produced will evaporate through this place and be collected in this gas series. Okay, how much hydrogen gas you produce shows you the rate of the reactions. Okay, now let's say the rate of reaction decreases as the reaction progresses. Of course, now the rate eventually becomes zero. Why? Because the lumps has all reacted. The zinc lumps has all reacted. All the acid is completely used up. Whichever all the lumps, lumps of zinc has been completely used up. So it's the concentration of the acid has decreased. Could be concentration of the acid decreased or the lumps is used up completely. Now explain why the rate of reaction decreases as the reaction progresses. Because the concentration of the dilute sulfuric acid decreases. Because the acid is being used by the lump to form something else. So it will reach a time the whole acid, the concentration of the acid is completely used, and there's no acid left to react with the zinc. Could be one of the reasons. Okay, you talk about in terms of concentration of the acid. You talk about concentration of the acid in this regard. You earn your 1 mark. The concentration of the acid decreases as the reaction progresses. Okay, that's it. Then another one is explain why the rate of reaction eventually becomes zero. Of course, because the acid has completely been used up, right? Because it becomes zero because the sulfuric acid has completely reacted. The sulfuric acid, there's no any extra acid remaining to react with the lumps of zinc. The acid has completely been used up, has completely reacted. Is that okay? It has been soaked completely. There's no acid left for the reaction to go on. That's why the reaction has become zero, or it has stopped. Now the next one is that experiment is repeated using a powder zinc instead of the lumps of zinc. Okay, in this case now the rate of reaction will be faster. All other conditions remain same. I explain in terms of collision theory why the rate of reaction increases if the powder zinc is used. Now in terms of collision theory is that the powder zinc has a larger surface area. So when you make something powder, you've increased the particle area. There are more particles. There's more collision. Collision per second will have increased. The collisions of the zinc powder with the acid, the frequent collision, there will be frequent collision. It's no longer like lump. The lump will be like waiting slowly to melt it or to dissolve it. That one takes a great amount of time. But when you make it powder, you've increased the surface area to volume ratio. You've increased the surface area. So there's a larger surface area. Since there's a larger surface area, the collision between the zinc powder and the sulfuric acid will increase. The rate of frequent collision between the zinc powder will increase. So you can break it into 2 points. This is 2 marks. In the exam, always break it to a point. Don't write one long sentence just like we did here. You say the surface area increases. 2, there's greater collisions or frequent collisions between the zinc and sulfuric acid. And you get your 2 marks. Okay, we go to the next one. The C part of the question says, the equations for the reaction is shown. You have zinc sulfate plus sulfuric acid to form zinc as a solid plus sulfuric acid, aqueous sulfuric acid. You get zinc sulfate plus the hydrogen gas. This gas is how much hydrogen gas we collect determines how much the reaction has taken place. Now here we have 25 centimeter cube of 2 mole per dm cube. This is the concentration, mole per dm cube. 2 mole per dm cube of sulfuric acid is added to excess zinc. Now calculate the volume of the volume of hydrogen and the volume of the hydrogen gas formed at room temperature and pressure, RTP, room temperature and pressure, and the volume of 1 mole of any gas at 24 decimeter cube at RTP. Now use the following steps. So the good thing about this aspect of chemistry, they give you tip, they give you formula, they even tell you, they break it down for you, or like other exam body, okay, or when you're doing A level. So here you say calculate the number of moles of this one first. They give you step guidance, so it makes it easy. They tell you to calculate the mole. You know, mole, number of mole is in this regard you can relate it to, since they give you concentration and volume. So we can use this triangular formula. We can use this triangular formula to do this one, right? Mole. We can use triangular formula to determine the formula. For example, we can say mole is here. Sorry, mole is here. Okay, mole is equal to concentration and volume here. So don't forget all these your triangular formulas. Okay, so mole equals to concentration and volume. So if you are looking for, since they say we should calculate the mole of this one, and they've told us about the concentration, they've told us about this concentration, but the volume we have to change from centimeter cube to decimeter cube, okay, by dividing it with 1000. You divide this, to change it to decimeter cube, you have to divide this one with 1000 to put it in decimeter cube. So they've given us the mole per dm3. This is the concentration. So we're going to say 2, the concentration is 2. So if you're looking for mole, you say concentration times volume. So concentration multiplied by volume, you say 2. The volume is what? 25 divided by 1000, it gives you 0.025. 25 divided by 1000, 25 over 1000 will give us 0.025. This will give us 0.025. In case you're wondering where in the world did we get 0.025 from? Okay, this is from the volume they've given us. We just convert it to decimeter cube. So you multiply 2 times this, you get 0.05 mole. Get 0.5. So the mole of sulfuric acid, you know, we relate molarity, okay? You see they all have 1 molar ratio. So the mole of this will be same as the mole of this, same as the mole of this, same as the mole of this. Why? Because they have same molarity ratio. If here was, for example, 2, if the mole of this is 0.05 and this one, the molarity ratio here is 2, you multiply this 0.05 with 2 in order to get the mole of this one. Okay? So this is how the game works. So that's for the first one. We go to the second one. He said, deduce the number of moles of hydrogen produced. Like I already explained. Because they have same molar ratio, hydrogen is same as the sulfuric acid we just calculated. So since they have the same molar ratio, the mole we calculate for sulfuric acid will be the same mole for hydrogen. But if this number was 3, we would have multiplied this answer with 3. Since this is unit 1. But if here was unit 2 and it gave 0.05, you do extrapolation. If unit 2 gave 0.05, this is what you do. If it was not 1, if the molar ratio was not 1. If unit 2 gave 0.05, this is what you do. You can find for unit 1 first. Or you just go straight to unit 3. And this one was molar ratio 3. If here was 3, you now say 3 equal to what? You put x, you cross multiply, and you find the molar ratio for this. But luckily for this question, they have the same molar ratio. So the answer will be the same, 0.05. Okay? Now we go to the next one. It says calculate the volume of hydrogen formed at RTP. Okay, volume has another triangle. You know, just now we use one volume formula. We say mole equals to concentration times this. There's another formula for volume. Another triangular, because there are 2 triangular formula you need to remember in the exam. The second one is the volume The second formula for volume is that volume, you put the volume here for the second one. Volume is equal to mole times 24. Volume equal to mole times 24 dm cube. This is also a volume formula, times 24 dm cube. So this is the second volume. This one, why are we going to use this one? Why are we not using the first one? Because this one, for hydrogen, we don't know the concentration. We don't know the concentration of hydrogen, but we know the mole. We know the mole. We just calculated the mole of hydrogen just now. So just multiply the mole with 24, you get the volume. Mole times 24, mole of hydrogen, see, the mole of hydrogen multiplied by 24 decimeter cube, you get the volume. So 0.05 times 24, you get 1.2 decimeter cube. So that gives us this 1.2 decimeter cube. So we get this answer. So the good thing about the chemistry for molarity, you need to revise your mole and the volume and all of these things and concentration. But the good news is that they give you steps, they help you. Because unlike they give you this question, from the beginning they just say calculate the volume of this one. Many students will be lost, except you really grab this concept very well. Now let's take a look at this D. It says hydrogen can also be produced by the reactions of zinc with dilute sulfuric acid. Right? Hydrogen can be produced by the reactions of zinc with dilute hydrochloric acid, not just sulfuric acid. Yes, because it's the same thing. Hydrogen will displace this, and zinc will displace this hydrogen to become zinc chloride plus the hydrogen gas. Now it says state the test for hydrogen gas. You know, test for hydrogen gas, you bring a lighter split, right? A lighter split close to the gas. Just bring a lighter split, like your, what do you see for those who smoke? Like match or like lighter. You just bring it near the gas. It will make boom, to make a pop sound. So lightest or least split or lighter split as the test, and the positive result is pop sound. Once you're able to do that, you get your 1 mark. Once you're able to write this equation, you get your 2 marks here. Is that okay? So that's that for this one. Let's move to the next question quickly. Question number 5. Okay, question number 5. Now we say that this question is about electricity and chemical reaction. It's about electricity and chemical reaction. Now, the aqueous copper sulfate is an electrolyte. Copper 2 sulfate is an electrolyte. Okay, copper 2 sulfate is an electrolyte. If aqueous, meaning is mixed with water. So copper 2 sulfate, if you dissolve it in water, what are the ions that we're going to form? Because it's aqueous, there's also what? Let's say dot 5H2O, for example. Okay. What are the ions? If it's aqueous, this is what we have. This is the solution. Now, if it's aqueous, meaning we will have the following ion. Copper ion, right? We have copper ion. That's 2 plus. The positive ion first. Let me write the positive ion. The next positive ion will be hydrogen ion, because there is water. Water produces both hydrogen ion and hydroxyl ion or hydroxide ion. Okay, these are the positive ion. What are the negative ion? We have sulfate ion. The negative ions will be sulfate ion, SO4 2 minus, sulfate ions, and hydroxyl ion, OH minus. So these are the ions, the 4 ions that will be in the electrolyte plate. Okay. Now these ions, some will migrate to the anode, some will migrate to the cathode, depending on what this thing is. Now it says the electrodes of aqueous copper 2 sulfate using inert electrode. If you use inert electrode, what are inert electrode? Platinum is an inert electrode, right? Carbon, like graphite. Carbon, I think, is also an inert electrode. So when you use inert electrode, the electrode itself will not be used up. Copper is not an inert electrode. If you use copper will either dissolve, the anode will dissolve, and the cathode will grow bigger. Okay? If you use copper electrode, those ones are not called inert electrode. But if you use inert electrode like platinum, like graphite. These are inert electrodes. So we use inert electrode. The electrode itself will not erode or will not participate. It will just be like a catalyst or something like that. Okay, so now this is what we have. These are the ions. It says state what is meant by the term electrolyte. Okay, electrolytes, if you want to define it, is 2 marks. And it's an ionic compound. You see I've broken it into ion, right? It's an ionic compound that is motile or in aqueous form. That is motile or in aqueous form, because it's always, most of the time, that motile or in aqueous form. So an electrolyte is a substance that dissolves in water to produce the ion. If you don't know how to put it like this, they say the substance that dissociate, when electricity is passed through it, it dissociates to produce the ions. Okay? When electricity is passed through electrolyte, it's a substance, when electricity passes through it, it dissociates to produce ion. It's either in motile form or in aqueous form. It's either in motile form or in aqueous form. And when electricity passes through it, it dissociates to produce ion. Okay? Or dissolve to produce ion. Whatever language. Dissolve to produce ions. Okay? Dissolves to produce ions. And I've put the ions here. You can see it will dissolve to produce these following ions. Okay, to produce ions. These ions will migrate or be discharged at both the anode and the cathode correspondingly, depending on, the positive ions will migrate to the negative electrode. The positive ion will migrate or will be discharged at the negative electrode, while the negative ion will be discharged at the positive electrode. Okay? So you get your 2 marks if you're able to define this. Now it says state the terms given to the Roman numeral 2 in the name copper 2 sulfate. It's the oxidation number. It has 2 oxidation number. Okay, copper 2 sulfate, you can see when we write it there, we write 2 plus, right? So copper 2 sulfate is the oxidation number of the compound. So these 2 represent the oxidation number. Now we go to the next one. Is it state what happens to the color of the aqueous copper 2 sulfate as the electrolysis progresses. Color fades away. Color gradually becomes colorless. Okay, the blue color copper becomes gradually fades to almost like colorless solution, fades away. So you get 1 mark. Now I say okay, before we reach here, I wish to maybe show you the electronics. I don't know if I can quickly show that. You have this, the battery or the source of power. Okay, this is your electrode. These are your electrode. This is the anode. And this is the cathode. This is the cathode. This is the negative side of the battery. This is the positive side of the battery. This is where you have your ions, the electrolyte, which is in motile form or in aqueous form. Is in motile form or in aqueous form. So these 4 ions are inside here. We have C plus, C2 plus, okay, we'll change the color. We have Cu copper 2 plus ions, 2 plus ions. We have hydrogen ion. We have hydroxide ion, OH. We have the OH ion. Because when electricity flows into this, it will dissolve into ion. To dissolve the aqueous solution copper 2 sulfate into ions. And then we have SO4 ions. Okay, these are the ions that will be present here. Why do we have, it's supposed to be only copper ion and SO4 ion. Why do we now have the hydrogen ion? Because it's aqueous. Aqueous means water. Copper 2 sulfate is mixed with water. Since it's mixed with water, that's why we have these 4 ions. Now in this case, this is the anode. Anode means the one connected to the positive side of the battery. The electrode that is connected to the positive side of the battery, while this is the cathode, the electrode that is connected to the negative side of the battery. Now, copper is lower than hydrogen in the reactivity series. So copper will be the one that will be discharged. Copper will be the one that will be discharged in the cathode. Copper will be the one that will be discharged in this cathode, right? Copper will be the one that will be discharged, not hydrogen. Hydrogen is, if you know, in this case, is the lower one that goes. Is the lower one in the positive side. The one that migrates to the cathode is the lower of the two. Hydrogen is copper is lower than hydrogen, right? Since copper is lower, copper will go. Okay, so copper will come here and it will form this equation. You say copper 2 ion will gain electrons. Why will it gain an electron? Why? Why do we use the word gain electron? Because electron will flow. Electron will flow to this one. So it will gain the electron that is flowing, that is coming from the battery. We gain 2 electrons. Copper 2 ion, we gain 2 electrons. We gain 2 electrons to become copper solid. That's it at the anode. So copper is produced at the cathode. Copper solid is produced, you can put this to show it's a solid, or copper atom, or copper molecule, whatever you want to call it. It's produced at the cathode. Okay? Why? Copper ion will migrate here, then electron will be discharged here. Electron that is flowing from this side will join it, so it will gain the electron and become a copper solid. Here, normally SO4 minus don't migrate. So what is available to migrate? OH. So the OH will migrate. OH minus will migrate to the anode. To produce, what will be produced if OH, anytime OH comes to the anode, what is produced? We produce oxygen. Produce oxygen and water. Okay? When OH comes here, oxygen and water is produced. Okay, so this is all about the electrolysis. Now let's see the question. Say, write the ionic half equations for the formations of copper at the cathode. We already did that. We say copper ion, when they migrate to the cathode, they gain 2 electrons coming from the battery. 2 electrons coming from the battery because it's connected to the negative side of the battery and become copper solid. So when you're able to do this, you get these 2 marks. Okay? Now it says give the formula of the ion that forms oxygen at the anode. Give the formula of the ion that forms is OH ion. OH ion will migrate to the anode and will produce oxygen. So if you want us to complete this equation, but although the question didn't ask that, once you write OH, you get the marks. You get this mark. But if you want us to complete, we can just write it somewhere here. OH minus, we produce water by losing electron, by losing 4 electrons. So here we're going to put 4 here. You have to balance it. By losing 4 electrons. Why is it plus here? Because it's on the right. If it's on the left, it will be minus, like it lost 4 electrons. Okay? If I'm writing it with it, it will be minus 4 electrons. But because I'm writing on the other side, so by losing 4 electrons, to produce oxygen. Can I write the oxygen first? Can write the oxygen gas first. Produce the oxygen gas plus water plus 4 electrons. So this is the equation at the anode. Is that okay? So these ones are always in multiple choice paper. So please know how to know what is happening at the anode, know what is happening at the cathode. Now let's go to the next question. Say the B part of the question says the electrolysis of aqueous copper 2 sulfate is repeated using copper electrode. Now if you use copper electrode, you know before we are using inert electrode like the platinum or the carbon. Carbon means the graphite in this regard. Now if you are using copper electrode, something happens. The anode will start dissolving. The cathode will get bigger. The mass of the cathode will increase. The mass of the anode will decrease. Is that okay? Now state what happens at the anode. Anode dissolves. It dissolves. The mass starts to depreciate, starts to decrease. and forming more copper ion. That copper ion continuously migrate to the cathode. So there will be more copper joining copper. You know, copper electrode is what is used. Copper ion joining copper electrode in the cathode, then copper will be getting bigger. More copper will be formed at the cathode, but the copper in the anode, because losing electron, will be dissolving and be fading away and becoming smaller. The mass of this one becomes smaller at the anode. Now we go to the next question, the C part. It says spoons can be electroplated with silver. Spoon, if you want to electroplate anything, the one you want to electroplate, put it in the cathode. The one you want to electroplate, put it in the cathode. The one you want to use to electroplate it, put it in the anode. Because the anode will dissolve and send it to the cathode. Okay? Now it said name the substance used as the anode. What will you use as the anode? Positive electrode. You should use silver, because you want to use silver to electroplate spoon. So put silver at the anode. Why? Because the anode will be dissolved. The silver will dissolve and go and add to the spoon at the cathode. Use spoon for cathode. Use the spoon at the cathode. Use the spoon to make your cathode electrode. And use silver to make the anode. Now the reason for this is that the one you are using to electroplate should be in the positive. The one you are electroplating itself should be in the negative. So this one in the positive, which is the spoon, the silver in the anode, will dissolve. We dissolve and we go to the electrolyte and be added to the cathode. So it will cover the spoon up. It will electroplate it by covering it up. That's the meaning of electroplating. Then the cathode, the negative one, should be the spoon. So once you do this, you get your 3 marks. The electrolyte should be aqueous silver or multi-silver. You should use silver. Why? Because silver, aqueous silver sulfate, okay? Aqueous silver, you should use silver something, not liver, silver. We want to write silver. This is a mistake, okay? Aqueous silver, not sliver, silver. Aqueous silver, S-I-L-V-E-R. It's a typo, okay? And the mistake was consistent everywhere here. Okay, correct it. This is a silver. Okay, so why? Remember, this is the logic. Remember, when we put copper, we use copper 2 sulfate, right? We use copper 2 sulfate. If you go and look for how you electroplate copper using copper electrode, the copper in the anode will dissolve and join this one, and then this one will dissociate to ion and send copper to the cathode. So the spoon, the silver in the anode will dissolve and join the silver sulfate or silver chloride, and then the silver will go and join the spoon to electroplate the spoon. Is that okay? So that's that for that. Let's move on to the next one. Now, state 2 reasons why spoons are electroplated. You electroplate spoon to prevent it from rusting, to prevent corrosion, rusty, and so on and so forth, and also to kill germs. Okay, these are the 2 reasons: to kill germs, to prevent it from rusting, and so on and so forth. Now we go to the next one. Hydrogen oxygen fuel cells can be used to produce electricity to power cars. Now, petrol produces carbon dioxide and carbon monoxide when it's power cars, right? Petrol produces carbon monoxide and carbon dioxide. Carbon dioxide can be harnessed by the trees to produce food. The carbon monoxide is toxic and poisonous in the environment, the atmosphere. So it produces gases that are not good when we use petrol. But the hydrogen one is a better one. The hydrogen oxygen used as fuel is better to power cars, right? Now state 1 advanced effect of carbon dioxide and carbon monoxide. One of the big problems is that carbon dioxide can cause global warming. We know this, right? It's part of the global CO2 and SO2 and methane. They are the part of these gases, the global warming gases, and so on and so forth. Then what is the effect of carbon monoxide? Is toxic. This one is poisonous and toxic. Can I poisonous or toxic? And then you get your 2 marks if you're able to give these 2 points. Now we move to the next one. State one disadvantage other than cost of using hydrogen oxygen fuel cells to power cars compared to using petrol. One disadvantage. Now they want us to state a disadvantage. One of the problems is that it's very expensive. So they already told you don't measure that. They already gave you that point. They want you to measure another point apart from cost because it's expensive. That's why we don't normally have hydrogen oxygen fuel stations where we can fill our cars and use it because it's a clean gas. It's good, right? Now one of the problems apart from cost is that it's very flammable. It's very flammable and it's difficult to store it. It's very difficult to store it. It's very flammable. So if you have hydrogen oxygen gas station or station where you power your car, any small thing the whole place can burn. The whole place can burn. It's very flammable. It has to be handled with extra care and super care. Okay? So apart from cost, so 2 disadvantages of using hydrogen oxygen is one is very expensive. Number 2 is that it's very flammable. Number 3 is very difficult to store. So if you give this disadvantage, other than that, it's clean. It doesn't cause pollute our environment. It doesn't cause global warming. It doesn't, So these are the advantages in case you are being asked in the following exam. Now here we are in question 6. Question 6 says that, let's hurry up because we have to finish quickly. Question 6 says that this question is about nitrogen compounds. This is about nitrogen and nitrogen compounds of nitrogen. Ammonia is manufactured by a reaction between nitrogen and hydrogen in the Haber process. Now, equation is shown. Nitrogen gas reacts with hydrogen gas to produce a reversible reaction to produce ammonia. Now, state the source of nitrogen. State the source of nitrogen for the Haber process. Of course, you get the nitrogen from the air. You get the nitrogen from the air, you get 1 mark. Now, state the source of hydrogen for the Haber process. Methane. We get the hydrogen from methane. Okay? We get the hydrogen from methane, or you can write from natural gas. Okay? We get the hydrogen from methane, natural gas, petroleum, whatever. You write, I think you get your 1 mark. Now, it says state the typical conditions used in the Haber process. Temperature 450 degrees Celsius. Pressure is 200 atmosphere. Okay? For Haber process. Okay? This is different from the contact process where we produce sulfuric acid. Now, name the catalyst used in the Haber process. Iron, of course. Iron. In the Haber process, the production of sulfur trioxide, we use what? Vanadium 4 oxide. Vanadium 5 oxide, right? This is vanadium 5 oxide. So, for this Haber process, we use iron as our catalyst to speed up the rate of our reaction. Now, state what is meant by the term catalyst. Catalysts are compounds that speed up rate of reaction without themselves getting used up, meaning they are unaffected, they are unchanged in the process. Now we move to the next question quickly because time is no longer our friend. Ammonia is converted into nitric acid, and the first stage is the conversion of ammonia into nitrogen monoxide, NO. Convert ammonia to NO. That's the first stage by reacting with oxygen, burning it in air in oxygen. In a reversible reaction, ammonia reacts with oxygen to produce reversibly nitrogen monoxide plus water. Now the reaction is carried out at a temperature of 900 degrees Celsius and a pressure of several atmosphere. And the forward reaction is exothermic. So the forward reaction produces exothermic and the backward reaction obviously will be endothermic. These are explanations that do not involve cost. Explain why the temperature less than 900 is not used. Why temperature less than 900? The rate of the reaction may become slow if you use any temperature below 900. So you will not have a faster rate of reaction and the quick production of the gas you are looking for. That's number one. Then he said explain why a pressure greater than 7 is not used. Anything pressure has to do with the shift of the equilibrium position. So when we say why you don't use pressure greater than 7, you say because the equilibrium position will shift to the left to now favor the reactant instead of favoring the product. The essence of the whole thing is to maximize the product, to maximize what you produce in the output. Not, because it's a reversible reaction, if you don't follow the strict conditions that maximize the product, you will get the product will reverse back quickly to the reactant. Just like if, in case of ammonia, when you're producing ammonia is changing back to nitrogen and hydrogen again. So what we give you maximum is what you're looking for. We're looking for conditions. So whenever we're talking about pressure in the exam, remember to always use the position. You don't want it to shift to the left. You don't want it to shift to the position of the reactant, because you want the product. You don't want the equilibrium to shift to this side. For example, you want to make this one, for example. So if you increase the pressure above 7, instead of maximizing the production of NO, the NO would have reached its maximum and it will start dissolving back to ammonia and oxygen again. So that's why we say when you go above the 7 atmosphere, it will shift the equilibrium position from favoring the product and start favoring the reactant. Meaning, you use the ingredient to make something, and the something is going back to the ingredient. So for pressure, this is how you explain pressure. For temperature, you talk about the slow, faster reaction to make the reaction to be faster or slower, depending on the condition that has been given to you. Okay, we move to the next one. In the second stage, nitrogen monoxide react with water and oxygen to produce nitric acid. So you see, balance the symbol equation for the reaction. They've written the reaction, they want us to balance. So balancing of equation, this one from grade 9, you should know how to do. Okay, you have to count the number of oxygen on the reactor side, the number of oxygen, you now multiply. 4 times 3 is 12. So all the oxygen here is 12. You must make sure the oxygen on the left is 12. 2 times 1 is 2. 3 times 2 is 6. So 6 plus 2 is already 8. 4 times 1 is 4. 8 plus 4 is 12. So oxygen is balanced now. So you put this number based on balancing. Nitrogen, you check. How many nitrogen you have here? 4. How many you have here? 4. 4 times this one, 4. So nitrogen is balanced. What else? Again, we have hydrogen. Hydrogen here, 2 times 2 is 4. Here, 4 times 1, 4. So it's balanced now. So you can see the number you write here makes it balanced. You get your 1 mark. Okay? Now, you say a student makes aqueous solution, aqueous copper 2 nitrate by adding an excess of copper 2 sulfate to excess of solid copper 2 carbonate to dilute nitric acid. Now, you say write the symbol equation for this reaction. Okay, this is easy. You write the copper carbonate plus nitric acid. You get copper what? You now get copper nitrate plus carbon dioxide, CO2, plus 1 oxygen atom here. We join with this hydrogen to form what? To form water. So you get this. You get your 2 marks if you're able to do this. Okay, we move to the next one. State 2 observations that indicate the copper 2 carbonate is in excess. Copper 2 carbonate is in excess. You still have, at the end of the day, you still have some dissolved solids. That's how you know it's in excess. You still have, at the end of the day, you have. And then another one is effervescence stop. Meaning, what do we mean? No more gas bubbling. No more gas bubbling. Effervescence means bubbles. Bubbles produce. Bubble of gas produce. It means bubble of gas produce. So if no more reaction is taking place, that means effervescence stop. Okay? It's about bubble. Okay? There are 3 words that fizzy. Another word you can say is a fizzy stop, or bubble stop, or effervescence stop. Okay? So that's how you know that it was in excess. It's more than the acid. You know the acid react with this. It's just like when we use zinc lump today and sulfuric acid. So the acid, if the reaction stop, it means the acid is completely used up. It means there's excess of this copper solid, because this is a solid, it's a lump. Copper carbonate is a big solid. So when the reaction stop, there will be no more carbon dioxide gas produced. There's no more carbon dioxide gas produced. Is that okay? All this one, if you want complete marks, you have to put the state symbols. Okay? Please put the state symbols. Put the state symbol, liquid. This one is aqueous. This one is aqueous. This one also aqueous. AQ. Aqueous is just AQ. This one is also aqueous. Put the state symbol if you want full marks. This one solid. This one solid. Okay, put the state symbols. Okay, so that's that for that. Let's go to the next question. Name one compound other than copper carbonate that can be added to dilute nitric acid to produce aqueous copper 2 nitrate. Yeah, apart from copper carbonate, we can put copper oxide, right? And we'll produce that. Then we get 15 marks for this question. Let's go to the last question. For the sake of time, let's be fast. The question is about organic compounds. Propane and chlorine react at substitution reaction. Propane and chlorine react at room temperature, and an equation for the reaction is shown. So one atom of chlorine remove one atom of hydrogen, so you have H7Cl, 1 Cl. The remaining hydrogen that is displaced, we join the remaining Cl to form hydrogen chloride, right? So you get chloropropane. Now state the condition required for this reaction. I told you this required a UV light, ultraviolet light, okay, in the beginning, because there was something like this. Even if it was not propane, it was the methane, okay, but it's the same thing. They belong to the same family. Okay, state the condition required for this is ultraviolet light. That's the condition. Then we go to the next one. It says draw the display formula of two structural isomers of the formula chloro. So I can have it at carbon 1, I can have it at carbon 2, right? So this one will be the structural formula. You can put it at carbon number 1 and then put the chlorine at carbon number 2. Is that okay? So we do this and we get our 2 marks. Let's move to the next one. Now alkenes are homologous series of hydrocarbons. Alkenes, you know alkenes, right? Double bond. They have double bond. Carbon to carbon double bond. At least there's one carbon to carbon double bond. Okay, like propene, like ethene, propene. Now, state 2 characteristics that all members of the same homologous series have in common. Oh, they have the same general formula. All homologous series, they have same general formula and they have the same functional group. All homologous series have same general formula and they have same functional group. Once you're able to state this, you get your 2 marks. So you can see chemistry, the solutions or the answers are short. You don't need to write so long to pass chemistry. Now, addition polymers are made from alkenes. Yes, alkenes, polymerize, add to itself to form polymers. Monomers of ethene add to itself to form this. Now, figure 7.1, complete figure 7.1 to show one repeat unit of the addition polymer formed from but2-ene. From but2-ene. But2-ene means you have at least CH3. Okay, you have double bond. The point I want to make, there's at least one double bond, right? But2-ene, okay, the double bond will be at carbon number 2. So here is one CH, then it's laggy. Then you have double bond here. Before you do the same CH and CH3. This is but2-ene. At carbon number 2, you have the double bond. Okay. So this one we add to itself to form this one. So draw this, we have to draw one single bond here. Because the polymer will be single bond, no more double bond. This is the monomer. When it polymerizes, you have this, right? 1, 2, 3, 4. To still show that it's butene we use. So if you don't have CH3 at any end, one on this end, one on this end, and you draw this single bond. You draw this single bond to show that it's now a polymer. This monomer, this polymer. They just want one single unit of it. You don't have to repeat. If we want to repeat, we'll do C to C again, H, CH3 on the other end. Okay, this will continuously repeat itself. But they just want one single unit. Now we move to the next one. Say, a repeat unit of condensation polymer is shown in figure 7.2. Now the polymer is made from 2 monomers. This polymer is made from 2 monomers. You can see carbon double bond to O, and then double bond to O here, to O, CH, and so on and so forth. Draw the structure of the monomers used to produce the polymer. The structure of the monomers that were used to produce the polymers. Okay, here we just show is a brief structure from one end and a brief structure from this other end that produce this polymer. Is that okay? Okay, even if we didn't show much details. Now here is a name the type of condensation polymer in 7.2. This is a polyester, right? This is a polyester. This is a polyester. So double bond to O and single bond to O on the other side. This is a polyester. And we get our mark. There is a name to homologous series to which the monomers in one belong. The homologous series, of course, once you see double bond to O, one is carboxylic acid, the other one is ethanol. Okay? Ethanol, like you can OH, right? You can, if we want, we can put H here. Okay, double bond to O, single bond to OH, single bond to OH. Single bond to okay, I think this is more appropriate. Okay, so one of it is alcohol and the other one is carboxylic acid. So you get 2 marks. One is alcohol. Which one is alcohol? This one. Double bond to O, single bond to OH. This is alcohol, functional group. This is this is carboxylic, double bond to O, COOH. You know carboxylic acid? They are denoted with what? COOH. COOH. And how do you show the structure? You see carbon, double bond to O, and then single bond to OH. Double bond to this O, single bond to this OH. This is the carboxylic acid functional group, and this is the alcohol functional group. Alcohol functional group, they are represented with OH. They are represented with OH. This is this OH. This is the OH for the alcohol functional group. This is the carboxylic acid functional group is denoted with this. Double bond to O, single bond to OH. The alcohol functional group is represented with this. It's represented with OH functional group. So, okay, with this we've come to the end of this paper. Thank you for joining us.